it's time to review some trig. We're going to start with theta being in quadrant 2 and knowing that the sine of theta is 4/7, and we want to figure out the other trig ratios. There's a couple ways to do this. The first way is to draw a picture and use Pythagorean theorem. So I've already got my angle here in standard position, and now I'm going to take another side of my angle, my terminal side, and rotate it into quadrant 2. And now in quadrant 2, I'm going to form my reference angle theta between the terminal side and the x-axis, and I'm going to draw my right triangle in there. And now on this triangle, sin is opposite over hypotenuse, so on this triangle I know the opposite leg is 4 and the hypotenuse is 7. And then I can do Pythagorean theorem, a squared plus 4 squared equals 7 squared, and figure out the third side, my adjacent side, is radical 33. And keep in mind we're moving left along the x-axis, so this radical 33 should be a negative. And that's all the information I need to get all 6 of my trig ratios. So for sin, I already know it's 4/7. So that tells me it's the cosecant, the reciprocal of sin, is going to be 7/4. For cos, cos is adjacent over hypotenuse, so my adjacent side is negative radical 33 over the hypotenuse of 7. And for secant, that's the reciprocal of cos. If I do negative 7 over radical 33, getting rid of the radical in the denominator will change it into negative 7 radical 33 over 33. And then lastly for tan, tan is opposite over adjacent. The opposite is 4, and the adjacent is negative radical 33. So that will actually turn into negative 4 radical 33 over 33. And cot is the reciprocal of tan, so that'll just be negative radical 33 over 4. Now our other option besides drawing the picture using Pythagorean theorem is to use what's called a Pythagorean identity. Sin squared plus cos squared equals 1. So if I know sin is 4/7, I can substitute that in right here for sin and square that. So then I'll use one of my laws of exponents. 4 squared over 7 squared will be 16 over 49 plus cos squared theta equals 1. I'll subtract 16/49 from both sides. 49/49 minus 16/49 is going to be 33/49. And that's how much cos squared is. So to get rid of the square, I'll take the square root. And that'll give me plus or minus the square root of 33 over the square root of 49, which is technically plain old 7. So now I have to decide, is it plus or is it minus? Well, for that, I need to know on my unit circle, all students tip cows. So we are in the second quadrant, so that means sin is positive and it's reciprocal. Cos is positive. All the other trig ratios are negative. So I'm going to pick the negative sign for cos. And notice now if I flip back, cos is negative radical 33 over 7. And then if I wanted tan over here, remember that tan is equal to sin divided by cos, so if I take my sin value and divide it by my cos value, these 7's are going to drop out, and there's my tan, negative 4 over radical 33, or negative 4 radical 33 over 33, which is the same answer as we had from using our triangle and Pythagorean theorem. Now, since we were told sin theta was 4/7, I'm going to go on my calculator and figure out how much theta is doing inverse sin or arc sin or sin -1. And I get about 35 degrees. So that tells me my reference angle is 35 degrees. So this little angle in here is 35 degrees. Now if I wanted that in radians, I could set up my proportion. Pi radians is 180 degrees. So how many radians is 35 degrees? And then I could cross multiply and get 35 pi equals 180x. Divide by 180. And there we go in radians. If I wanted to put that in simplest form, I could divide the numerator and denominator by 5, which will make this into a 7 and this into a 6. So 7 pi over 36 is right around 35 degrees. Now also, if I know that that angle is 35 degrees, I can figure out my angle of rotation that I rotated to. That would be 180 minus 35. Which would be 145. And then my coterminal angle simply goes the other direction. So that would be 180 plus 35, which would be 215. On your unit circle, when you rotate to 30 degrees, cos of 30 is radical 3 over 2. Sin of 30 is 1/2. So remember, the first coordinate is the cos, the second coordinate is the sin. At 45 degrees, the cos and the sin are the same, radical 2 over 2 and radical 2 over 2. And at 60 degrees, it's the reverse of 30 degrees. Cos of 60 is 1/2, sin of 60 is radical 3 over 2. Now, these are helpful reference angles. Anytime you rotate to a multiple of 30, 45, or 60, you can know the exact value for sin, cos, and tan, and sec, cos, and cot. So let's go with 11 pi over 6 radians. How many degrees is that? Well, pi is 180 degrees. So we're going to do 11 times 180 divided by 6, which is 330 degrees. So a rotation of 330 degrees is going to go 90, 180, 270, and 60 more, which leaves us 30 degrees as our reference angle, 30 degrees short of 360. So then I'm just going to refer to my 30 degree angle. Sin of 330 degrees, or 11 pi over 6, is going to be 1/2. But remember, we're in the fourth quadrant where cos is positive, so that'll be a negative 1/2. Cos is going to be radical 3 over 2, positive in the fourth quadrant. And tan is going to be sin divided by cos, so negative 1/2 over radical 3 over 2. The 2's are going to drop out, which will leave us negative 1 over radical 3, which in simplest form would be negative radical 3 over 3. And lastly, let's do a quick little talk about equation of a wave. Good idea to always start with the midline, or the line of equilibrium. The A in the front is the amplitude, the depth, or the height of the wave. And the F is the frequency. How many waves happen between 0 and 2 pi, or 0 and 360 degrees. And also, you have to figure out whether you're choosing sin or cos as your trig function. Remember, sin is going to go cross the y-axis at the origin, whereas cos is going to cross the y-axis not at the origin. It's going to look like that. And the other vocabulary word involved with waves that is not involved in this equation is the period, which you can calculate if you know the frequency. You simply take 2 pi and divide it by your frequency. So if you have 3 waves that happen between 0 and 360, 2 pi divided by 3 will be the period. And likewise, if you know the period, you can change this equation around to figure out its frequency. So if you do 2 pi divided by the period, it'll tell you how many waves happen between 0 and 360.